All right, so let's look at number 6 here. 6 says, determine the similarity ratio of the two quadrilaterals. Find indicated side lengths and angle measures. So we're given with these two quadrilaterals, and we're told that quadrilateral BRKE is similar to quadrilateral YPWU. This is really important because it helps us match up corresponding pieces, right? So we have the angles B corresponds with Y. We know B corresponds with Y. And then the side from B to R corresponds with Y to P. So BR and YP. Then we have R corresponding with P. So angle R corresponds with angle P. Then we've got RK corresponds with PW. So RK and PW. And we can just keep going around. So the next one would be K and W. Angle K corresponds with angle W. And then KE corresponds with WU. Again, I'm just going in order. Then we've got angle E corresponds with angle U. They're the last two. So E corresponds with U. And the last side, EB, corresponds with UY. There we go. Now, we know that they're similar, okay? How are they similar? What is their similarity ratio? If I want to find the similarity ratio, I need to compare the side lengths in these two quadrilaterals. I can only do that if I know the sides, the corresponding sides, and their measures in each, right? Like, think about this. The green side here, I don't know how long it is. The green side here, I don't know how long it is. So I have no information to plug into a ratio in order to find the similarity ratio. How about the blue side? Here, I know the blue side is 10, that's promising. But here's the other blue side, I have no information. So when we do this, we need to look for two corresponding sides where we know the side lengths of both. That only happens for the pink sides here, right? The red, we only know one of the two. So the only ones that I could possibly rate are the two pink corresponding sides. So I'm going to do that. We're going to relate RB to PY in order to find our ratio. Now we know RB is 5 and we know PY is 4. Here's our similarity ratio. Now you could go ahead and get a decimal, right? We could do 5 divided by 4. We get 1.25. That also works here. But if you were to divide and get a decimal that is not exact, that does not finish, that you would have to round, then you don't want to use it because it's going to give you inaccurate information when we use it in our next step. So you can only do this if you don't have to round it. Otherwise, just use it as a ratio, as a fraction. Now we're asked to find WP. So let's set this up. WP corresponds with RK. So if I start on the left and then the right, I can say that RK over WP, that is the similarity ratio, right? Remember before we were setting it up, we said that RB over PY is equal to RK over WP. I can say it's equal to BE over UY. And the last one, I could say it's EK over WU. So we're just comparing them all. I know that all of the similarity ratios equal the same thing, right? So RK over WP, whatever RK and WP are, has to equal 5 over 4. So let's plug in what we know so far about RK and WP. RK, we know is 10. WP, we don't know. That's our unknown. But we know that when we do this, if we knew what WP was, it would simplify to 5 over 4 or 1.25. So now we have to solve this. Now, if you leave it as a fraction, it's kind of nice. We can solve by cross multiplying. So here I could cross multiply. 4 times 10 is 40. And the question mark times 5, let's go ahead and put an X for the question mark for what we don't know. So X times 5 is 5X. So we set those two equal. And now we just have to solve for X. So I divide both sides by 5. And I get that X equals 8. So that tells me that WP then must equal 8. So that was kind of a lot of steps, a little bit confusing. Let's repeat it again for EK. Okay, I'm going to go through the same process, really follow along. See if you can set it up first. If not, just follow along. Okay, so here we go. We've got EK. EK is the side length here. It's red. And so it corresponds with the one UW. All right, so we started on the left, then on the right. So when I set up the ratio, we're going to do EK over UW. And we'll plug in what we know so far. So we don't know EK. Again, I'll let that be X. But we know UW is 6. So it's X over 6 so far. Now we know that every similarity ratio in the same problem is going to be equal. So I could say that this one is equal to 5 over 4. And so now to solve this, again, I can go ahead and cross multiply. We're kind of ignoring this part right here. We're just going to focus on these two fractions equal to each other. I'll cross multiply. 6 times 5 is 30. And it's equal to the other cross multiplication. 4 times X is 4X. And so now we're just going to solve for X. So to solve this, I would divide both sides by 4. You can use your calculator for that. 30 divided by 4 is 7.5. So for this one, we know EK, the distance must be 7.5. So we're using this ratio to solve for the missing side. So now for the angles, remember that when you have corresponding angles in similar polygons, corresponding angles are congruent. So angle U is right here. We know that angle U corresponds with E. They're congruent, so that means the measure of angle U must be 90, since angle E is 90. How about for the measure of angle K? Well, angle K is right here. It corresponds with angle W. And since corresponding angles must be congruent, I could say that K is 66 degrees. Next, let's go with angle Y. So angle Y is right here. It corresponds with angle B. And since corresponding angles are congruent, I know Y must be 124 degrees. And now the last one, angle R is right here and it corresponds with angle P, but I don't have information about either of these two. How am I going to find them? Well, so far with everything we've filled in, I know that, B right here is 124, so is Y. I know E is 90, so is U. And then K, I know is 66, like this one. So let's fill in K right here. Let's just write down that it's 66 so that we have all the information in one quadrilateral. Now we have everything but R. Here's a property that hopefully you know, and if you don't, that now you will remember about quadrilaterals. In a quadrilateral, all of the angles sum to 360 degrees. Okay, so think about for the triangle, remember triangle sum theorem, it was 180. So it goes up now. For a quadrilateral, it's 360. All right, so for this, If I want to find the missing, kind of like we did when we were with triangles, I'm going to take the total, which is 360, and I'm going to subtract the ones that I know. So I know that we've got one that's 124. I have one that's 66, and the other one is 90. So I'm going to subtract those. If it helps you, we've got 360 minus 124 minus 66 minus 90. And there we go. Oops. We are left with 80. So that means that angle R must be 80 degrees. So this all over here was to find the measure of angle R. And then if I were to ask you for the measure of angle P, you could simply tell me that that one also must be 80 degrees. All right, let's look at 7. 7 says, if two figures do not have congruent angle pairs, what can you conclude about the figures? Do you need to measure any sides to determine similarity? So let's see. We have two figures, and they do not have congruent angle pairs. Their angles are not congruent. What can we conclude? Right away, I can conclude that they are not similar. Because one of the properties of similar polygons is that all corresponding angles are congruent. So if even one of the corresponding angles is not congruent, if one pair is not congruent and all the other ones are, it doesn't matter. All of them have to be congruent, not just one or two. So do I need to measure the sides and try to find the similarity ratio? Do I even need to test the similarity ratios? No, you do not. What a waste of time. This is enough information to tell you already that these are not similar. So you don't even need to spend your time trying to find the similarity ratios. Let's look at 8. So in number 8, we have quadrilateral YPQR, which is similar to quadrilateral TBNC. And we want to complete the proportionality statement. So we're creating these proportions where we are really just matching up corresponding sides. So we'll start here. We have YP first. So YP goes from the first letter to the second letter in the first quadrilateral. The corresponding side would be from the first letter to the second letter in the second quadrilateral. So YP must correspond with TB. And we fill that in right there. Same thing for the next one. P to Q goes from the second one to the third one. So I repeat the same thing in the other quadrilateral. The second to third would be B to N, I'm sorry. Now for QR. So Q to R are these last two, Q and R. So the last two in the second quadrilateral are N and C. There we go. And then the last proportion, we have RY. So R is the last, back to the first one. We go from C to T. And here's the proportionality statement that matches up those corresponding sides. And it shows how the proportions are all equal.